Hello, friends. Today we are going to study the last part of this chapter, that is the reactions of azo compounds and the reactions of aniline. We have already started the reactions of azo compounds. The reactions of aryl diazonium salt or azo compounds. It shows two types of reactions. The first type of reaction is reaction involving displacement of diazonium group, that is N2 group. We have already studied these 6 reactions in our last lecture. Today we are going to study the reactions involving retention of diazonium group, that is the reaction in which N2 group remains as it is but X group is replaced by some other group. So in this second type of reaction, the first reaction is reaction with phenol. When benzene diazonium chloride is reacted with phenol in the presence of alkali or base like NaOH or KOH, you can see the chlorine and hydrogen gets eliminated and para-hydroxyazobenzene is formed. OH group remains as it is, but the hydrogen from the para position gets eliminated, as well as chlorine atom also gets eliminated, and para-hydroxyazobenzene is formed. The structure is benzene ring, two benzene ring. In two benzene ring there is two nitrogen atoms. Therefore, this reaction is retention of azo group. Nitrogen group remains as it is, and para-hydroxyazobenzene is formed. The similar reaction is with aniline. When benzene diazonium chloride is reacted with aniline in the presence of base like NaOH or KOH, base is also called alkali. So para-aminoazobenzene is formed. Again, the hydrogen of aniline and chlorine from benzene diazonium chloride gets eliminated. N double bond N group remains as it is, therefore it is retention of azo group, and the product formed is para-aminoazobenzene. Now the third reaction in the retention is reaction with benzene sulfonyl chloride. This test is called Hinsberg test. This benzene sulfonyl chloride is called Hinsberg reagent. It has a molecular formula C6H5SO2Cl. So reaction of benzene sulfonyl chloride, which is called Hinsberg test. This benzene sulfonyl chloride is called Hinsberg reagent. Now the reaction is when Hinsberg reagent, that is benzene SO2Cl, when reacted with primary amine SO2Cl, primary amine, that is NH2C2H5, the hydrogen and chlorine gets eliminated and N-ethyl benzene sulfonamide is formed. Now this N-ethyl benzene sulfonamide, nitrogen carries one hydrogen atom. As nitrogen contains one hydrogen atom, it is highly acidic in nature, and therefore when this N-ethyl benzene sulfonamide is dissolved in water, dissolved in base like NaOH or KOH, it gets readily soluble in base because nitrogen carries one hydrogen atom. But if the same reaction, when Hinsberg reagent is reacted with secondary amine, that is C2H5NH2H5 or C2H5 twice NH, here also the HCl gets removed and the product formed is N-diethyl benzene sulfonamide. But this nitrogen in N-diethyl benzene sulfonamide does not contain hydrogen atom, therefore it is not acidic in nature, and therefore it is insoluble in base like NaOH or KOH. So this is Hindenburg test is to distinguish between primary amine and secondary amine. When Hindenburg reagent is reacted with primary amine, then the product will remain soluble in base. But when Hindenburg reagent is reacted with secondary amine, the product formed will be insoluble in base or alkali or NaOH or KOH. So this is the test to distinguish between primary and secondary amine. Now, these are the three reactions in which retention of nitrogen group takes place. Now, next part we are going to study is reaction of aniline, that is C6H5NH2. Benzene is attached to NH2 group. It is called aniline. First reaction is bromination reaction. We have already seen in the haloarenes or phenols. Same reaction is there also. When aniline is reacted with bromine in the presence of water, 2,4,6 tribromoaniline is formed. That means 3 bromine atom gets attached to one aniline ring. Therefore, a white PPT of 2,4,6 tribromoaniline is formed. If the same reaction, when aniline is reacted with concentrated nitric acid, that is concentrated HNO3, this reaction is called nitration reaction. And when aniline is reacted with concentrated nitric acid in the presence of concentrated sulfuric acid, then a mixture of product is formed. This concentrated nitric acid and concentrated sulfuric acid together, they are called nitrating mixture. So when aniline is reacted with nitrating mixture, a mixture of para-nitroaniline, meta-nitroaniline and ortho-nitroaniline is formed. You can see in the first product, NO2 group is attached at 4th position, whereas in the second product, NO2 group is at 3rd position, that is meta position, and in the final product, NO2 group is attached at 2nd position, that is ortho position. But the percentage of products is different. Para-nitroaniline is nearly 51%, meta-nitroaniline is 47%, and ortho-nitroaniline is only 2%. So therefore, 3 products are formed. But in industry, para-nitroaniline is a very important compound. Therefore, for nitrating mixture or nitrating reaction, if you have to obtain only para-nitroaniline, you don't want to obtain meta-nitro and ortho-nitroaniline, then this nitrating reaction must be carried in the presence of acetic anhydride. See this reaction when aniline is reacted with acetic anhydride, CH3CO OCOCH3. This compound is called acetic anhydride. In the presence of pyridine, acetanilide is formed. When this acetanilide is reacted with concentrated HNO3 in the presence of concentrated sulfuric acid, now due to this acetanilide group, NO2 group gets attached at para position. Therefore, para-nitroacetanilide is formed. And when this para-nitroacetanilide is reacted with water, then para-nitroaniline is formed. So, this is also nitration reaction, but the product is only para-nitroaniline. But in the above reaction, the products are different. There is a mixture of product, that is para-nitro, meta-nitro and ortho-nitro. So, para-nitroaniline, to obtain para-nitroaniline, acetic anhydride is used. Now, second reaction of aniline is sulfonation reaction. When aniline is reacted with sulfuric acid, it may be dilute or concentrated. Anilinium hydrogen sulfate is formed. You can see only H2SO4 gets added, NH3 plus HSO4 minus is formed. When this anilinium hydrogen sulfate is heated at 453 to 473 Kelvin temperature, this SO3H group gets attached at para position. Therefore, product is sulfanilic acid. Sulfanilic acid in which there is aniline and SO3H group is at para position. It is also called para-sulfonyl aniline. But this sulfanilic acid exists in a dimer stage. It shows a dipole structure, dipole ion, in which again another structure of this sulfanilic acid is benzene ring, NH3 plus charge and SO3 minus. So the hydrogen gets shifted from SO3H to NH2 group, and therefore NH3 nitrogen carries positive charge and oxygen carries negative charge. This ion is called Zwitter ion. In the exam, once there is a MCQ has been asked, what is Zwitter ion? So the Zwitter ion contains benzene ring in which it is attached to NH3 plus group and at para position SO3 minus group. This is called Zwitter ion. So here we have completed our chapter. In the next lecture we will start with a new chapter. Thank you.